Hello students, now we'll learn about superposition principle. First let's watch a video on ants and see how they work with forces. Okay, so let's see how the ants eat food. So the ants come around the food like this way. There are many ants. Each ant will give a force. So this ant will give a force here, this ant will give a force here, like this way. They know only to pull, they don't know to push the food. So like this way, each ant will pull in different directions, but some ants will give more force like this way. So the food will travel in the direction of the greater force. So you have to add all the forces. This is kind of superposition principle in nature. Okay, now okay. According to the superposition principle in electrostatics, the total force acting on a given charge is equal to the vector sum of forces exerted on it by all the other charges. Now let's take a charge here. Let this charge be q1. Okay, now this charge will be act upon many charges in nature. Let's see another charge here. This charge be q2. Okay, and this charge be q3, and this charge be q4, and let this be qn. Okay, now q1 is acted upon different charges here. q2 will give a force like this way. Okay, this is a force on 1 due to 2, f12, and the distance between q2 and q1 will be r21. That will come to little later. Now let's see the next one. The force between q3 and q1, like this way, we'll mark it as f13, force on 1 due to 3, and the next one q4 will give a force like this way. This force will make it as f14, force on 1 due to 4, and this one, this is the nth charge. There are many charges here. This is nth charge, so this force will be f1n. Okay, now we have to add all these forces vectorally. These forces are vectors. Let's see the distance here. So distance between q1 and q2, this will be r21. This is actually position vector, distance between 2 and 1. And next one, this will be distance between 3 and 1 is r31. Okay, then the distance between 4 and q1 will be r41, and the distance between q1 and q1 will be rn1. We'll see why we use this distance a little later. These are distances are all vectors only. Okay. Now let's see the force on 1 on q1 due to q2. That will mark it as, we can write as f12, force on 1 due to 2. That is equal to k into q1 q2 divided by r21. See, the distance is 21 square into r cap 21. This is actually unit vector. It shows direction. Force a vector quantity, so I write a vector. Next, force on 1 due to 3, f13, is equal to k into q1 q3 divided by r31 square r cap 31. Okay, now similarly f14, force on 1 due to 4, like this we can write. I'll write as f1n, force on 1 due to n, that is equal to k into q1 q2 divided by n1 square to r cap n1. Okay, now we have to add all the forces vectorially. So the total force, you can write your force on 1, the total force is equal to force on 1 due to 2 plus force on 1 due to 3 plus force on 1 due to 4, and so on up to force on 1 due to n. So these are vectors. Now let's add them. So now we can see force on 1 due to 2, that will be k into q1 q2 divided by r21 square r cap 21. Now k is common in everything, so we can take it out. Right, let's say to bracket here, plus the second one q1 q3 divided by r31 square r cap 31, plus and so on. You can write here. Okay, now I'll write for 1 for also q1 q4 divided by r41 square r cap 41. Okay, so it will go like that way. So let me write for nth charge here, plus this one will be q1 qn divided by r n1 square r cap n1. Okay, I'm writing it down a little bit. So this is a superposition principle. So what happens here, net force, so you can write here F1 total is equal to sum of all the individual forces. This is superposition principle in nature.